What's up, class? How are we doing chemistry? I hope you are having a good Tuesday if you're watching this. What we are going to do today is I'm going to give you a short description of what it means to be soluble and how we measure solubility using curves. So I'm going to teach you all about the curves and all that kind of stuff. Okay, let's do this. So just a quick review. You remember that it means to be soluble means you can be dissolved. All right. And insoluble, these are things that don't dissolve. So oftentimes we'll talk about oil and water. Oil happens to have a nonpolar structure, and when molecules of water interact with it, they don't like each other. So things that are insoluble are things that don't dissolve in water. Now, there's more than just oil, like sand doesn't dissolve in water. If it did, our beaches would disappear, but salt does. And so different substances, you have to look at them and look at the components of them to figure out if they dissolve or not. So I want to talk about electrolytes. So electrolytes, when you put electricity in, um, what will actually happen is they will conduct electricity. So I remember this time we were on marine bio. We're in the middle of the ocean, a mile away from shore, and a storm rolls in. And all I can picture is that we're in an electrolyte. We're in salt water, right? And if lightning strikes, you're in trouble if you're in an electrolyte. But if you're in a non-electrolyte, like for example, if you were in a tank of oil and lightning strikes, you'd probably be okay because it doesn't conduct electricity. So understanding how to tell the difference between them is the key thing. So electrolytes, these are things that are salts, and salts are a metal plus a non-metal. So for example, KCl is a great example of a salt that does conduct electricity, whereas things that start with C and are not made of ions, they're non-electrolytes and don't conduct electricity, so the lights don't go on. Now, this one you can tell totally is an electrolyte. So when we write the dissociation equation, you write Mg plus 2 Cl minus. And the reason we write 2 is there's 2 right there. We have to balance it, right? And so this is actually a really great electrolyte because it really dissolves into plenty of ions. Now, today, what we're going to talk about is how to speed solutions up, how to make it go faster. So one way that you can make it go faster is by temp. If you increase temp, more collisions occur, more molecules come in, and they are able to dissolve faster. If you agitate or stir, right, you're going to dissolve faster because the solvent comes in contact with the solute. And finally, if your surface area is smaller, so if you take small bits versus large bits. If you have rock salt versus powdered salt, the salt that's granular is going to go way faster than the chunks of rock salt. Okay, I meant to put that in yesterday, but alas. All right, now we're talking limits. Okay, so if you like sweet tea, there's actually a limit to how much sugar you can put in. So we call these limits. They're referred to as like saturated, unsaturated, and supersaturated. Okay, so if you're saturated, this means you're completely filled with solute. You're full. That's full. So saturated means you can't put any more. It's reached its limit. And there should be no apostrophe there. My bad. So it reached its limit, and what ends up happening is if you add any more, they just fall to the bottom. So you can see that a saturated solution. So eventually, like if you're making iced tea, right, you can reach saturation, and the sugar just goes on the bottom. Now we know that if you have ice and you put sugar in, it doesn't dissolve. But if you heat it up, that's how you make sweet tea. You heat it up, then you can change its limit. So the limit is temperature dependent. How much you put in is dependent upon the temperature. And typically, as temp goes up for most things, solubility goes up for most, especially for solids. For gases, it's kind of opposite. There's a few that aren't. My battery is dying. Hopefully, I can make it through. Now, unsaturated, these are solutions that are not full, and they need more. Okay, so not that they need more, but if you put like a little few crystals of sugar in iced tea, they barely dissolve, right? And so, or they dissolve right away, and there's more room. So this one is you can add more. And because chemistry is awesome, there's this thing called supersaturated, which what happens with this, and if you get a chance, YouTube supersaturated solutions, they're really cool. you add these are when you heat stuff up really, really hot, and then you cool it down slowly, and it's actually holding more than it should. So this is holding more, and what happens is it's really unstable. Like you shake it and it all falls out, and so crystals will form if disturbed. So keep in mind it's this way. This is filled up, so this is full. This is not full of solute, and then this guy supersaturated is too full, right? And it's going to come out. Normally we'd make it in lab, but I'm not there. Sadness. Okay, now the biggest thing is that you understand how to do these curves. So let me explain how this goes. So for different salts, and you'll see this in the activity at the end, the solubility, as you increase temperature, and temperature's on the x, that'll increase the solubility. And this line is the limit you can put in 100 grams of water. So if I take 50 degrees Celsius and I have KCl right here, do you see it holds about 42 grams in 100 grams of water? That's the limit. So if I have 40 grams, I can add more, and that would be unsaturated. So if you're below it, you're unsaturated. If you're on it, if you're at 42, that's saturated, man. You can't put any more in. And if you're above it over here, you're super saturated. So this curve, you just have to understand how to use it, how to work it, and all that. So I'm going to go through a couple things. So first off, 10 degrees. Okay, so which substance down here is the least soluble? Well, it's this guy right here. So let me get rid of this because it's in the way. So it is whatever this is. Let me move it's KClO3. Oh my gosh, I should know that. So KClO3 is the least soluble because it is the lowest at that. Now, what's the highest at 10 degrees? You would say this guy right here, right? He has the most. It can hold almost 8, it can hold 80 in 100 grams of water. It's always 100 grams of water. So we said NaNO3 is the most. And then what is the solubility of KCl at 40? So we go here to 40 and we go up, and you can see that it's about 40 grams, right? That's 40, right? In 100 grams of water. And if I increase the temp, I can increase the solubility. Got it? Let me give you a couple other problems. So when we express it, we always express it per 100 grams of water or 100 milliliters. Basically, the density of water is 1, so there you go. But if I were to double the amount of water, guess how much salts I can put? I can put twice as much. So in 200 grams of water at 40 degrees of KNO3, so here's KNO3, do you see I can hold 65 grams per 100 right here approximately? And you can read the graph, whatever, just get close. So in 200, I can do 130 grams because it's twice the amount. 130 grams, that's crazy. Okay, we go on to the next one. All right, now, I love these questions where they ask you, is it saturated, is it unsaturated, or super? Okay, so let's find 47 grams in 100 grams of water. That's right here at 50, so that's right about here. Do you guys see that's over the line right here? So that means it's super saturated. And what about 20 grams at 50 degrees Celsius? So here's 50, and here's KCl, 3 right here, and at 50, it's like really close to, I don't know why I did that, but it's really close. So it's probably just slightly super saturated. Okay. And then, oh no, I see what it's saying. In 200 grams of water. Okay. So I switched up. So in 100 grams of water, it can hold 20 about, but in 200 grams, it can hold 40. So this is unsaturated because I have twice the amount of water. It's not, I can hit up to 40 or about 39. Okay, so that's how that works. Okay, so final thoughts. It's really about reading graphs and understanding the limits. If you're saturated, you're on the line. If you're unsaturated, that means you're below the line. And if you're supersaturated, that means you're holding too much. If by chance you forget, it's always per 100 grams of water. If they double or triple the water, you can triple the amounts of the lines. And that's pretty much how you read solubility curves. You guys are going to do like an online thing now with your lab partner, but it's pretty easy, and I think you'll get the gist. All right, that's it for all. Take care.